All right, hi Algebra 3-4. This is This is pages 5 and 6. Oops. 5 and 6. So we did this in class. So first period, this is really for you because we had a rough day. But it's for anyone who maybe missed class or just wants a little bit more explanation. So the first thing I want to do is highlight this. So inverse functions are functions that reverse each other. So if I take something from A to B, the inverse takes B to A. And so the one thing we talked about is that this notation, I'm going to do this. So this is the inverse of f of x. It's notation. It's not an operation. Not an operation. So that's a really common misconception because we're used to exponents, right? And so we want that to mean something. We can have negative exponents, but because it's sort of on that f, that means something different. And so the other thing that we talked about in second period, because again, first period, I want that sort of maybe up here. We had some issues. So one thing we talked about was how this is the input, and then I get my output. Yeah, so B is my output. And then my output becomes my input, because why not? So then I get a new output. So then my inverse takes my original output and it makes me have a new input, which happened to be my original input. So one thing that a student sort of said, I think quite nicely, was sort of what this picture is showing us, is that A and B flip, right? So my input and my output sort of flip. They swap places. The other thing you could, so instead of A and B, you can do this, which means my double arrow here, that my inverse would be the opposite. Cool. Okay, so the other thing we talked about in class was finding the inverse for this given function. So when they say f, they're talking about that function. And then it wanted you to consider, okay, before you do that, how would you find f inverse of 8? And so I think what I did in second period that I didn't do in first period was this. I said it out loud. So f inverse of 8. That's how you would say that. Sorry. And so the input is now 8. So remember that they flip, though. Remember that they flip. So we talked about how we could find this. Some people talked about division, multiplication, right? Sort of undoing this function. But really, let's look at this line here. I'll put a star by it. So if I know that I have, how did I write it? I wrote a question mark. So then I'm going to have this arrow thing happen because I know that I have this. My input is now 8. So that had to mean that my original output was 8. Yeah. So it's so clear. We love this. So this is what I'm going to use. And I think it says it right here. So to find f inverse 8, we need to find the input that corresponds to the output of 8. So that's this line. So then what we did in class is we said, okay, I'm going to have my original function, and then I'm going to solve. It's a nice little x equals 2. So what that means is that f inverse of 8 equals 2 because the original function, if I input 2, I output 8. Yep. Okay, so that's that idea. It's a lot of ideas. So here it uses y. And so one thing you will see, so some teachers will do like this. I don't know. I don't like that for a lot of reasons because I feel like without the parenthesis x, without the function notation, it really does look like an exponent, right? Like it truly does. And so the difference for me is that this reminds me that -1 is not an exponent. Yeah? Because our next unit is logs, so just we're going to have tons of exponents. So that's why I personally prefer this notation. You can, so this is also a way to write it. Oops, I don't want that. Hold on. You didn't see that. Move. Thank you. Appreciate it. Can also write, oops, as, right? You can do that. All right, anyway, so then here we're going to find the inverse. So, it doesn't really say. Well, that's okay. You're going to solve for x. So, I'm going to highlight x. X is here. I want that one x all by itself. And so this is stuff we've been doing for, millennia. Feels like it this year. -2, -2. I'm going to leave f of x in there. 3x, divide by 3, right? Divide by 3, the whole thing by 3. So I'm going to rewrite it over here. F of x minus 2 divided by 3 equals x. Okay, I solved for x, right? Check. But it doesn't look like an inverse, so I need the notation. So I'm going to say now, rewrite in function. I'm going to say inverse, I guess. I don't know what else to call that. Notation. Oops. Notation. Okay, here's what I do. I literally draw an arrow. And I say this equals. I'm going to use blue. Just let me. And then I'm going to say -2 divided by 3. Okay, so x was my input, now my output. See how that changes? I still want to graph, so we write it like this because, right, like this, because we can graph it, we can evaluate, we can make a table, I can understand what it means. Like I can understand the function a little bit better, right? So that's why I want to rewrite it, is because now I'm thinking like, okay, and again, you could write it like this. Oh dear, I really don't like that way though, right? So I could make like an XY table. I can make a table for this. I can graph it. I have an input, output. I can do everything the same way. Okay, we did this first one in class in second period. So same thing, right? +5 divide by 2. So here, maybe I'll scoot. It'll just be tight on the PDF, and that's okay. So g of x +5 equals 2x divide by 2 divide by 2. Dun, 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 dun. The whole thing equals x. So here's my switch. That is an x, not a y. Oh my gosh. So I'm going to do this. And here, I'll do it over here. That's my inverse for number 1. The other thing I asked you in the slideshow is what type of function is this? So this is also linear, just like for the record. Oh dear. Solve for x, and then rewrite it. Okay, cubic. We also did this in second period. First, we did not get to this, and I apologize. Here it is. -2, right? Just like we've been doing. This is all the same. We talked about how we undo a cube. We do a cube root, because that's the inverse operation. Shout out to the inverses. I'm going to rewrite it in purple, and then I'll move it over when I have. So I'm going to use h Oh, see how I did? Sorry, that's supposed to be G. My bad. I do that a lot. Equals cube root x minus 2. So I want to have only one h, one x. Yeah? Okay, so this is a cube root. So cubic and cube root. Interesting. Very interesting. Ooh, she messy. Okay, let me just... I'm sorry, y'all. Well, I'm not surprised, though. Oh, so one thing, so we just had this happen. So linear. Oops. If I have my inverse, it was linear. Just wanted to do this for you. And then I had a cubic. We'll call, oops. And then I had a cube root for my inverse. Oh dear, that's an R. Interesting. Oops. Just think about it. Just think about it. Just think. Okay, so cube root now. So I'm going to go the other way. I'm going to make this bigger. Okay, so same thing. We're going to solve for x. When in doubt, solve for x. Solve for x. I think this is page 6. That's also doesn't look like an x, does it? No, it does not. Okay. This is multiplication. I don't particularly like that way with the dot, but that's okay. I'm going to go over here. So I have f of x divided by 4 equals cube root of x. To undo a cube root, I'm going to cube the whole thing. So I'm going to rewrite it in pink. F of x is the numerator. 4. I'm going to make my parentheses be bigger. My huggy boys. Oh dear. So then, and then I'm going to have, what would it, f equals x divided by 4 to the third power. So there's elements that are the same. So here I'm, like I have a 4 over here. I have a cube root. Here I have a cubic, right? So there's elements that are the same, but we can't just like flip stuff. So if we had a table, we could, but we don't. And that's for a different reason, because I've already like done my operations. Okay, number 4 is complicated. So keep that in mind. Hopefully you tried it on your own. If not, I would recommend pausing and trying it on your own. It's, no one likes to solve these. Some of you I had for Algebra 1, 2, and this was part of our solving unit. And I'm like trying to find my key right now. And no one likes it. Hold on, that wasn't part of it. Sorry. Okay, so I'm going to zoom out. Can I zoom out? I can. Just go with it. Okay, so we want x by itself. I have x in top and bottom. I can't cancel those out. It's two different things, so just bear with me here. So the first thing I'm going to do is I'm going to multiply both sides by the denominator. So here, let me actually highlight what I'm going to do. And I'll try to color coordinate. So both sides. Okay. So then I'm going to have x minus 2. And I think I just did g. I'll do g of x. It's a lot of parentheses. Equals x minus 3, right? Because these are going to go to 1. Okay. So then what I did next is I distributed the x and the 2 to my g of x, right? And so remember that like g of x is just like y or something, right? It's just like the output. So it's okay. It's okay to do this. So I'm going to say g of x times x minus g of x times 2, right? I'm going to do that in parentheses. Equals, so this other side is untouched. Okay, so this doesn't have an input, right? It's just my g of x. So I'm actually going to add that to both sides. I know. So I'm going to add, my shorthand when I did this by myself was a lot messier. So I'm trying to be more like consistent. So that's going to go to 0. So I'm going to have g of x times x equals x minus 3. Do I need to multiply this? No, I don't. Plus, I'm going to leave the g of x out front. 2. Okay, sweet. So then I have this x here, right? So I need to move this to the other side. So I'm going to minus x on both sides. So I'm going to have this like term again. Times x minus x equals, and then I'm going to put my g of x first because it's positive. Minus 3. Oakley dokley. So the other thing, I'm going to do dark blue here. I have an x in each term, so I'm going to factor out an x. So then I'm going to pull that out. I'm going to have a g of x then just in here, minus 1. Right? Because if I like distributed, it would be like back. And then I have this, g of x times 2 minus 3. Oops. Okay, so what I've done is I've set up a scenario where I can divide by this purple part, now it's pink, on both sides, g of x minus 1, right? Because that's gone. I know, you didn't think it was possible, but I assure you, all is coming. So then I'm left with just my 1x, which is what I wanted. I'm going to make this other part be purple. And then I have g of x times 2 minus 3. And then I have this. I don't need parentheses down here, but you get the idea. Okay, great. So now we're going to rewrite. So x becomes g inverse of x. G of x, the little one, becomes x. So that's what's happening here. So let me draw my little arrow. G inverse of x equals, so I have a, oh, what is that, 2x, hey? I'm gonna, because that's how we do that in regular math land. Wow. Okay. Yeah. So in a regular year, we would do more with those. We have a whole unit for rationals because they are this gnarly all the time. So just know that like you won't necessarily see this, like I wouldn't put this on a test, for example, maybe for like a challenge problem, but otherwise I wouldn't. And then I'm going to make that be down here. It's a lot of work. Okay. So just thanks for hanging with me. So what I want to say up here though, real quick, is that I had a cube root and then that went to a cubic. Down here, you're like, I'm traumatized. Rational went to, it's still rational. Interesting. I wonder why. Okay. I know. It's okay. The challenge problem. So this one after number 4 really does not seem that bad, in my opinion. So it requires you, though, to know what these are, I guess. Maybe if that part's challenging. So this first one is linear. It is a linear. Right, so I'm thinking about my inverse. I guess I want to maybe write that it is starting off as linear. Maybe I'll do that. And this is cubic. And then this is our beloved rational. And then this is a radical. Or a square root, you could say. Okay. So let's think about this. So a square root, radical. Well, you know what? Actually, let's start with what we know. We just did this. So this is rational. This is on the slideshow too. Cubic is cube root, right? Like we knew that. So therefore, by default, and I have a big like funny arrow on my slideshow. So a radical is the inverse of a square root. So I'm going to say that quadratic and radical are inverses. So that was like the one that was missing. Cool. Okay, that was long, but number 4 is kind of gnarly. So anyway, I hope you have a great day. Bye.